This is my first YouTube video doing technical stuff. I'm always busy repairing and inventing things, and friends and colleagues keep saying I should make videos of that. I never bothered because I think it will slow me down, but then again I also learn a lot from videos that others post, so maybe it's time to give something back. Anyway, if you're trying this repair, it's at your own risk. I haven't tested how durable it is, so I won't accept any responsibility. The subject is an electromotor with a brake that is not working. I replaced the brake a few years earlier when it was worn out with a rubber disc, but the rubber tends to stick and then the brake won't disengage. So we're going to replace it with real braking pads, and I wasn't unable to find an official disc for this type of motor. So I kinda winged it with some brake pads from a motor, and that is what this video is about. So I remove the core of the engine, of course use a piece of wood as to not damage the axle, and we'll put that apart, get the motor out of the way, so we can get the anchor out of the end. I'm using a pulley to get it out. It's a tedious process because it's a press fit, it's all very tight, but you don't want to damage anything. So take it slow. First time I had to get it out, I didn't have a pulley, so I used a hammer to hammer it out. I wasn't careful enough, so I damaged the axle and then had to repair that again, which took more time than necessary. You can see the rubber pad that I put in a few years ago. It was a hard rubber, but it's still worn out quite a bit. It's time to replace it, and it tends to stick to the metal disc, the brake disc, and then it won't disengage. It has to disengage when the magnetic field becomes imminent. It has to disengage like that. And you can see all sorts of rubber sticking to the disc. It's of course not good. So let's get the old disc removed, the rubber pad, so we can put in a new one. It's not hard, 4 screws. Hopefully see, I've done this already one time. So I made a mold with 3D printer to check if the holes are in the right place. That's important. You can of course make a mold with a piece of wood and a hole saw. I didn't need to test if the holes were in the right place because I used the mold before, and now I can use the mold to get an optimal fitting on the brake pads. I used brake pads from a Honda motorcycle. They were cheap and gave a lot of surface area, but there remains a gap, so we have to weld them together using some scrap metal to get a disc shape after we grind the pattern out. The outside isn't very critical, but the inside has to fit the bearing from the anchor, so that has to be the right size. And since the screw holes are near the center hole, I didn't want to make it any larger than necessary. I sped up the footage a little, so the video wouldn't be too lengthy, but I guess the picture is clear of what to do. Of course, don't forget your safety equipment, wear glasses, your eyes are valuable, and a green mask might not be a bad idea with the dust coming off from the brake pads. Overall, the grinding went pretty smoothly. I was a bit worried up front that the brake material might come apart, but it kept its shape quite good. By the way, since I discovered the brake is wearing down so fast, I use a piece of scrap wood to assist braking, to make brake disc last longer. That also helps. Once the disc have the right shape, you have to weld them together. I didn't film the welding itself. I was a bit worried that the camera might not survive that. I tried putting a welding glass before the lens, but I thought you couldn't see anything anyway, so it wouldn't be that interesting. But as you could see on the first shot with the mold, there is a little bit of spacing between the two pads, about 8 millimeters, that you have to bridge to make it in a disc shape. And that's why I already grinded out the hole in the center, because once it's welded in a disc, you can't grind that anymore. In the end, it was a little bit too tight, the center hole, so I had to use a file to smooth it around a bit so the bearing would fit. Here you can see the disc shape welded together. I have to get the ends right. I'm doing it here. I used short welds, a little bit at a time, because I didn't want any risk of melting the brake material. It should be somewhat heat resistant, because braking of course generates some heat, but when the iron underneath is melting it might get loose, and I didn't want any of that. And now the ends are also grinded down. As you can see, it is looking pretty much like the mold we made with the 3D printer. I've already put in some holes. I used a drill press to get the holes at the right spot. I didn't film that either because it's too dark where the drill press is located. But if you are going to attend this, I can imagine you know how to drill holes. Use some brake cleaner to clean up the metal disc, get rid of all the old rubber, because I don't want to stick it again, surely. I mean, the whole purpose of this repair was that the brake was sticking, the motor wasn't starting up, because the rubber stuck to the brake and it wouldn't get it to turn and to disengage. So no more rubber on the disc, and real brake pads this time. Of course, you have to countersink the screws. And first time when the brake was worn out, it was braking against the screws, which wasn't very good for the disc, and it made a terrible noise. And after some filing, the disc goes around the bearing, so now it can be mounted. So let's get ahead and do that. Might be a good idea to use some locking agent, which I obviously didn't do, but I don't expect the screws to come loose anyway. Well, the brake pad is mounted. We need to put in the core again and get the bearing. It's a press fit. There's some two sort of spring rings in there, maybe to get it tight against the other end. Put it in slightly. I'm not going to hammer it in. That was maybe a first thought. Just press it in lightly, and we get it in by turning the screws on the outside, and you slowly work it in so that it's all tight again. With aluminum, I always try to get a start by hand, just for not to damage the threading. But once it is in, you can use a wrench. Okay, now I'm going to slowly get it in. Turn each rod a bit at a time because I want to keep it straight. So I sped this up quite a bit, because otherwise it would be too long. I want spend any time making any strange cuts, but as you can see, I work it in slowly until it is tight again. And now, of course, the final test to see if it turns and breaks. Well, that seems to start and stop just fine. Of course, I forgot to put on the cooling fan, so I gently tapped that on. Should have used a piece of wood maybe, but I just tapped gently. And I hope this video is of use to anyone who has to replace the brake of his motor.